So the take-home message about the valley networks is that almost universally scientists do think that they are associated with the activity of water. And so the presence of these valley networks early in Mars history would argue for water being much more active in the first billion years of Mars's history. Again, this is just showing some of these valley network features. As you all made the connection, it's very natural to think of these as dried up river basins. So we won't go through the alternate explanations because we've already talked about that a little bit. But in terms of water, there are two basic mechanisms that have been put forward to explain these valley network systems. The one that you all were thinking of when you're talking about a river system eroding those channels and the river flowing to some sea or something. Well, how would that work? If these valley network systems, don't look at this yet because this is the explanation number 2. What would be involved for these to be river systems?
I mean, you would have a flow of water which eventually settles into like the easiest route for that,
Okay.
gradient and whatnot, and that constantly gets eroded.
Right.
Gets
So if we think about the Mississippi River system, how does the water get into that system?
Some kind of source, like brook, or
Okay, so the tributaries feed into the Mississippi River, but how does the water actually get into those surface channels? Where does it come from?
water cycle.
Water cycle. Okay, so what are we talking about with the water cycle? Okay, rain falls on the landscape in a very broad distributed fashion. The water that doesn't sink into the soil flows across the surface, eroding a little bit, eventually collecting into channels, which collect into brooks, which collect into rivers, which flow down to the sea, and then the water gets dumped back into the ocean, and then the rest of the water, continuation of the water cycle, puts the water back up in the atmosphere, it precipitates down, process starts all over again. So if we were talking about river basins, we're talking about a fully functional hydrological cycle or water cycle as we would experience here on the Earth, and leading to rivers cutting the landscape and then leaving those river channels when the water became scarce. Okay, so if these valley networks are indeed river basins, then that would imply that at some point in the past there was rain on Mars. At some point in the past there was a functioning hydrological cycle. And I don't know about you, but I find that a fascinating question. Did it ever really rain on Mars? Was Mars ever sufficiently Earth-like that we would expect an Earth-like water cycle? Because I can't think of a question whose positive answer would turn Mars into an Earth-like place more so than that question. Okay? But rain and river erosion is not the only way to get these channels cut across the landscape by water. The alternate explanation would be groundwater sapping. And I don't think I'm going to take the time to go into this in a lot of detail, but the main difference here is that we may never have rain and lots of water running across the surface of Mars, but still have the ability to have groundwater, layers of water, layers of subsurface that have lots of water flowing through it, and that water flow going through these subsurface layers can gradually erode channels back up the hillside. So if you've got an area where some water-rich subsurface layer is coming out into the open, then that movement of water underground can essentially lead to an undercutting of the bank, and if that gets eroded enough, it eventually collapses, and that groundwater coming out, which might immediately evaporate in the atmosphere because the atmosphere isn't thick enough to sustain a hydrological cycle, would that undercutting would eventually eat a channel upstream. Whereas we think of river erosion being stuff washed from upstream down and the flow of water downstream kind of carving the channel. So this works kind of backwards from the kind of typical water cycle that you're familiar with thinking about here on the Earth. We do have groundwater sapping occur on the Earth as well, but it's less obvious, and it's not what people tend to think of when they think of the water cycle. Here are some examples of channels being cut by groundwater sapping. This is out in Arizona, actually, and you can see these stubby channels that are being carved back into the hillside and up the slope. So whereas a river kind of starts at its finest tributaries and works its way down, these groundwater sapping channels, like I say, start at the bottom and eat their way back into the hillside. As a result, they don't have that same kind of dendritic, finely branched systems that we tend to think of for something like the Mississippi River, where you've got all these minor rivers and streams and creeks and so forth branching off. So how to tell the difference? Some of these valley network systems look like they could be very dendritic branched, but if you look at something like Nergal Vallis that we looked at before, you really don't see a lot of branching here. So is this really an example of a river erosion, or perhaps this is just some channel that's been carved, eroded out from the hillside by this groundwater sapping working its way kind of upstream, every now and then making a little branch, but not providing the same kind of fully branched surfaces. So there's been a big controversy back and forth between those scientists who would be promoting a fully functional hydrological cycle and water running across the surface of Mars and fully formed rivers exposed to the atmosphere, where you might expect Martians with their boats, going up and down the canals. No one's talking about that anymore. But there has been this debate between these two camps. Do we have in these valley network systems evidence for a fully functional hydrological cycle, or is it all just groundwater stuff? And there's never really enough atmosphere to allow for fully fledged rivers to form on Mars. And I think